Hi everyone, my name is Ryan Booz. I'm a Postgres advocate with Redgate Software. This is day 5 of Advent of Code for the year 2022. And as I've said in the previous videos, I'm certainly far behind these daily puzzles. But really, as I have an opportunity, I'm trying to solve day by day using just PostgreSQL and SQL and the functions provided with Postgres, trying not to dive into custom functions or stored procedures using a different language, whether it be PL, PGSQL, or Python or something like that inside of Postgres. So the attempt is just to use SQL and the functions provided as a base install of Postgres to solve the puzzles. So day 5 was interesting, and I knew that we were going to start to get into, as I read this challenge, to get into recursive CTEs, because I knew I would have to process multiple things iteratively. And in pure SQL, the easiest way to do that, doing something and then using that result set for the next task is to use a recursive common table expression, or CTE. So let's go ahead and talk about what the puzzle was. So in this case, it says that the elves are about to leave camp and they have all these stacks of boxes, and they have instructions on how to reorder the boxes in the stacks. And then because they need to get to specific boxes. And so you get a set of instructions that give you a bunch of movements. And when all the movements are done, the boxes that are on top are what we need to know so we can get the things out of those boxes. And so this is what the puzzle looks like. This is an example of the description. So in this case, they're saying, hey, if we have 3 stacks, it starts like this. And these are the 4 commands you're given. The crane will move the boxes from stack to stack. Now in puzzle number 1, there's going to be one important detail which I missed, and I'll show you when I solve it, is that this movement, move one item, so in this case, move 1 from stack 2 to stack 1, that's easy enough. I'm just going to move D from here to the top of here. So it's going to stack over. So they give you that example below, and we end up with 3 in the first, 2 in the second, 3 in the third. Great. Now the problem is the second command was move 3 boxes from stack 1 to stack 3. And so I just was assuming we would take all 3 boxes and move them. I didn't read closely, and that was my thing. Right here it says the boxes need to be moved 1 at a time. Oops, I just missed that. I just missed it. So as you go through the commands at the end of the day, when all is said and done, you're going to end up with some kind of stack using the example. This is what it looked like. And then we need to know the letter of the box that's on the top of each stack. So in this case, the answer would have been CMZ given this example data. So somehow we need to take that data, get it into a form in SQL that we can use it and move it forward. So let's see at least how I approached it. First of all, here's the input I was given. In this case, there are 9 stacks, not those 3 in the example. So 9 stacks, no stack at the beginning has more than 8 items in the stack. And then there's a line break and then all the move commands. So it's one text file, which we had to do something with. So the way I approached it is how I've done it with the other day so far. I imported this data just into a table. Every line in this text file became a row of text in a table, which I could then process with SQL. So that's how I approached it. And then as I'm looking at this, I recognize that somehow, for me at least, I see this as the first thing that jumped out to me is something like an array, right? I'm going to get each column. I need to figure out how to get each column into an array or a string or something so that I can start to iterate over that string or array in a meaningful way. So that was my attempt. Now, I will admit that probably caused me to struggle more than I should have, because I was so focused on trying to do this with arrays that it just took me a while to figure out how to make that happen. After I eventually got it, I did look at some other solutions from community members and realized I probably could have done it a lot more simply. 2 people in general use JSON. So they actually did kind of get the array, but then quickly put it into JSON, because in Postgres, JSONB has things like a JSONB set function. So it's actually a little bit easier to iterate and reference those various stacks in a JSON representation than maybe I did it in the arrays, or faster to get to that solution, put it that way. So what does that look like for me? So As I've shown in other videos, I just create a simple table with an ID column. The ID is an identity, so it's generated for each row. So as the copy command inserts row by row, we get an ID with that row. And that's just, as I've said before, I don't know when it will be useful. It might be useful at some point. It turns out for me, it was useful today just to get things going. So you'll see this looks just like the text file I showed you. It's just that these are individual rows. Maybe that's easier to see it this way. Individual rows in the database. All right, so the first thing I needed to figure out was how to get those first 8 lines, right? So if you look at first 8 rows of my table, how to get this from multiple rows with 9 positions in them to 9 stacks or arrays of information. And so initially, I thought about 1 or 2 ways to do it. Again, I use the ID column here. I could have easily said, where there's a square bracket in the entry, right? So those first 8 lines are the only lines in this entire file that have the square bracket. So I could have filtered just on that. I didn't have to use the ID column, but that's how I chose to do it. So it didn't take me too long to realize, okay, this is consistent. I can just reference the position in the text. Position, in this case, position 2 is the first box identifier. Position 6 is the second box identifier for every row in my text file, in my text string for every row. And so that didn't take me too long to figure out. And so I could create these columns. So I'm just simply re-representing what was individual strings, but now I literally have 9 individual columns that look exactly the same, but now it's a table of data. They're rows with multiple columns. And so I can aggregate those rows in Postgres into arrays or strings. So I did originally try to do this with an array aggregation. I thought it might be easier to do a multi-dimensional array. So I have one array with a bunch of arrays inside of it that I could easily just say, take X from array 1, basically slice the array and push it on to the other array. I thought I might be able to do that. I forgot in my first attempt, I don't even have it here. That's not possible because in Postgres, a multi-dimensional array, the arrays have to be the same length internally. And so you can see immediately, even in the first 2 columns, we have 2 very different lengths, right? We have one with 5 letters and one with 8 letters. So that just didn't work. I struggled for a little bit trying to see if I could make it work, and I gave up because the arrays are going to keep changing in size as we move boxes around. It just wasn't worth it. So I decided instead the array was helpful because then I could, for each time I'm working through this process, I can take one thing, refer to an internal element in that array, happens to be a string instead, to get it out. So what does this end up looking like? So I take the columns, I aggregate each column into its own string, and I'm filtering out the nulls because the nulls, don't matter, quite honestly. So what does that look like? It ends up looking like this. So I have one array with 9 strings internally. So now I can refer to any one of those strings by their position, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is convenient. I didn't have to figure out other columns and so forth. So now I have one thing I can keep iterating about and moving around. So that got pretty long, right, to have these multiple things. I thought, is there a way to simplify this? Do I have to have all of this down here? Well, no, I can just simply take that substring, put it into the aggregation, do the null reference here with the string ag, and I end up with the exact same thing. So great. I just hit Control Enter for dbeaver, and I got the same result. All right. So now I have the array. I have the initial state of the stacks. And as I said, I kind of knew that at this point I had to figure out how to work row by row and start to move things around. So this is where recursive CTE comes in handy. And so I actually decided, I'd already recorded this video, and I realized I did not do a great job showing you what the recursive CTE was doing. So I want to work through that with you. This is a little bit longer video. Hopefully it's helpful. So the first thing is, great, I have my stacks, but I still need to know the arrays, the movements that happen. So in Postgres, the easiest way to do that for me at least, was to do something like a regex match. So we have these functions regexp, and in the match case, again, the text is the same every time, right? So I can take this text, and if you don't know regex, you can look it up, but basically anything in these parentheses is returned as a value. So I'm simply looking for the individual integers within the string at the defined positions. So what does that look like? Well, if I just run that, oops, I got to get rid of that. So now, again, it's going to process every row. I didn't filter anything else out. I could have said, where line does not contain move or something like that. I didn't. I don't really care, to be honest with you. It just wasn't important to how I was going to solve the puzzle. But now, starting with row 11, that was the 11th line in that text file, we start to get our movement commands. And so move 5 boxes from stack 8 to stack 2. Move 2 boxes from stack 4 to stack 5, and so forth. There are approximately 400, maybe 400 lines of instructions of movements to get to the end result. So now I have a table of stacks and I have a table of moves, right? So now I need to do something with that. And this is where the recursive CTE comes in handy. So let's talk about a recursive CTE briefly, and I'll try and put a marker in the video of this so that hopefully I can refer to it separately. The way recursive CTE is done in really any SQL language, it's a SQL standard. First, I have to include this with recursive. That says that somewhere internally, one or more of these CTEs are going to refer back to themselves, and the form is always the same. Number one, you have to first set up the form of the result from this common table expression here. In this case, I called this one game. So you always have to have the first setup. This is what the table is going to look like in any initial values you want. And then it's going to union the result of this function, of this query over and over again. So first set up the table, that's your first row or rows, whatever it is. It's the initial state of your table. And then it's going to run the second query, and it's going to keep running the second query until there's no results left. And the nice thing about a recursive CTE is I can refer back to the result set that just came out, right? So every run, the first run, you're getting the static query up here. That's your result set. Then it runs again, and it runs this second query. And if this query refers to itself, it's referring to the data that came out of the first iteration. So in this case, the first iteration is your static query. You can refer back to that. And then the result is whatever comes out of this query. It's not the union of both, it's the result of this query. In the end, it is all union together. So essentially there are kind of 3 tables in a CTE. The first is your first query. The second is just the result set from each iteration. And the third is what's happening internally. It is unioning all of the results in an internal table, which it will then return at the very end. So let me show you what is really happening here. So I started with ID 11. Remember I said I could have, rather than pulling out the ID here from those move lines, I could have done a row number here and just started from 1. There's a number of things I could have done. I just decided to use the ID that I had. Therefore, I'm starting from ID 11, right? So I have this initial state, ID 11, 0 boxes. I'm not moving anything yet. I just need to get the columns in state. However, I am selecting, remember, I only have 1 row here, or I have 1 row of an array. And so I'm selecting the 1 row from my stacks, which is that array of strings. So that is my first, when this runs, that's what's shown. So essentially, this is what comes out the first time through that recursive CTE. Now I join it to the other table of moves. And you can see this moves table has lots and lots of rows, right? So I'm going to join it. So this is my second query. So it gets that first row out, great. Now it goes to the second row, and here's my select statement, right? I'm going to bump this up just so I can really show you. I'm selecting the ID of my join, so that's the game ID plus 1, right? So iteration number 1, this table is called game, because that's what the CTE is called. The ID was 11, 0, 0, 0, an array. The next iteration, I'm taking the ID, which was 11. I'm making it now 12, because I'm going to reuse this. You'll see in a second how I'm reusing this. The boxes is now going to be from my join. So I have that move table. So now I'm going to start to fill it in with how many boxes from the first row, what's the source, what's the destination, and then the resulting state. So I'm going to do something with that array. I'm going to select that out. And so I'm basically taking, I'm shifting one row at a time through that movement, but I'm able to refer back to the previous row that came out of the CTE. So the first time through, I get 11, 0, 0, 0. I join it to the movement table based on, somewhere I have it using. Where is it using? Oh, it's right here, sorry. I join it to the moves table with ID. So I have 11 and 11. So the first row, joining it to the move table. Okay, so now it's the first move. I can then take the information, cross-lateral means now I have essentially a table that looks like this, right? Internally, the second iteration, I'm now working with this table, right? So I'm taking that table. Remember in one of the earlier videos, I said when you do a cross-lateral in Postgres, anything that's inside of the cross-lateral means it can refer back up to what is above it, the outer query. So now I have access to all of these in order to spit out a new row. What's that new row going to be? Well, it's going to join. Remember, I'm joining. I lost my cursor there. So now I have access to both the original row and this new row in the moves table. And so using that, I can split that stack state apart. Remember, it's the original stack state. So let me flip back. This is the original state. It was my first row. So I can refer to that and I can say, hey, if I forgot one other thing. So unnest. So I'm going to take that stack state and I'm going to unnest it. So it's an array of 9 elements. I'm pivoting them back to 9 rows. And in Postgres, with ordinality says, spit out the row number along with it. So what does that look like? So this unnest, remember, I'm just working on one row. And so the unnest ends up looking like this, right? I added this group state just so I had something to aggregate on. And honestly, I probably didn't need that, but at some point along the way, I added it. And so I took this array, turned it back into 9 rows. So now I have something to identify which one of these rows is the one I need. And now I can say, hey, if the ordinality matches the destination column, go ahead and select what I need from the array, because remember, I can still reference the array that's there. So from state stack, find the array that matches my source column, right? If it's the destination, go back to the array, find the one that matches the source column, and just substring out the characters I need. In this case, 1 to X, right? Number of boxes. And then just append it. So append it onto the string of this current row. So what's happening is it's working through this row by row. So I'm just going to append to that string. I just happen to call it I because it was easiest. When I did the unnest, notice I did a reference here. All right, so there's the reference. It unnested to 2 columns, and I got an I and an O. It's just what I called it. So if it's the destination, take the number of characters off of the source inside of the array, add it on. If it's the source, just substring it using, and again, in Postgres, it's we're talking about this string, and just start with, remember we're 1 offset, so I have to go to the number of boxes plus 1, so that let's say it was 3 boxes, I need to get to the 4th character, and I'm gonna take from there forward, essentially popping off the characters from the beginning. If it's neither the source or destination, just output the string as it is. And then I'm going to simply reaggregate that back into an array with 9 elements. So after the second iteration, this is what comes out of the function, right? So this row is what comes out. I have a new array that is reorganized. Internally, what's being built is this table. That's what the union is doing internally, but that's not what's coming out each time. So internally now I have this. And remember, I can now join. So now I'm going to go to iteration 3. Iteration 3 says join on ID. So let's go back up to the moves table. ID 12 is 2, 4, and 5. All right, 2 boxes from 4 to 5. So on the third iteration, or I guess the second, right? I'm now going through it. I had my initial state. I've done one iteration. Maybe I'd say the second iteration. I'm joining those two. What comes out is technically ID plus 1, so 13. So the next time I can join to the right row. 2 boxes, 4, and I've moved things around a second time. So now, after 3 iterations, this is what we have internally. And it just keeps going, right? So the next time, it's going to join to row 13 in the moves table, which is 3, 3, and 9. And then it's going to add 1 so that it just keeps going. So in this case, I'm only ever getting 1 row. That's really my main point here. Every time this join is done, this recursive CTE is done, I'm only getting 1 row out of this internal query here, right? So in total, whoa, that's not, let me get out. That's not what I meant to do. Out of this select statement, I'm only getting 1 row. And I'm only getting 1 row in this case because this join right here, there's only ever 1 matching ID on both sides. And so that's why, if it were, recursives are often used for parent-child relationships. So the typical ones like an employee and manager. A manager is an employee of a company, but also manages multiple people. Well, if a table has, an employee ID and a manager ID, that join might reference multiple rows. Therefore, this select statement would get multiple rows. In my case, I know it's only ever going to get 1 row out, and I can just keep referring back to that row. I hope that was helpful to try and explain how this problem is solved and what the recursive CTE is doing. So in my case, I'm going to bump down 1 or 2 so I can get more on here. So in my case, I'm using that internal state. I just keep iterating and iterating. I'm shifting the strings inside of that array. They're getting big sometimes, small sometimes, big sometimes. It's just moving around and around and around. And when all is said and done, this is what it looks like. So after it iterates the union of all of them, I'll say select star from game. I think it's game. Let's see. What did maybe it's games. Oh, sorry. In dbeaver, if you, I added these, if you add, anyway, it's just a dbeaver anomaly. If I add spaces in a CTE, I would have had to select it all. So you can just see as I go, there's sometimes where, for instance, down here, you notice that some of the stacks end up with nothing on them, right? And that's okay. It's just moving things around and we're getting nothing. And eventually, when all is said and done, we get down to the last one. So let me go ahead and do this, right? Now the final move, select star from final move. Not hard there. And so this is the last state of that array of strings. Okay, great. So I have that array of strings, and now I need to get the first letter from every element in this array. And honestly, the easiest way for me to do that for me was to simply say, look, I'm going to nest every element in this array, and then substring get the first letter. Now, if I just did this, then I end up with this, this is annoying, right? So if I just did that, I'm going to do that. I end up with the rows, right? So because I nested it, it moves it back into rows, and I just get the first letter of each word. And so I just wanted to aggregate it. So I'm going to do one more string aggregation so I finally get the letters together in the string, which is what the puzzle required to do. So I had to give an answer. Now, the problem is I did all that. I got this answer. I put it in, and it said I was wrong. I was really frustrated, partially because it took me a little bit longer on this recursive CTE. And then it's like, what are you talking about? Well, it turns out, remember I said I missed the fact that on the first go around for star 1, you have to move one box at a time. Well, essentially I could take, let's say I'm moving 3 boxes, I just have to flip them around because that would be like moving the boxes one at a time. So simply doing a reverse on that substring gets me a different answer, and that turned out to be the right answer. And then guess what? For star number 2, it said, hey, it turns out that the elves didn't realize that this crane can actually pick up multiple boxes at once. It's not required to just do one box at a time. And so all I had to do to solve star 2 was just take off the reverse. So it turns out what I was getting first was actually the answer to the second puzzle. I didn't know that because you don't get the second puzzle until you solve the first one. So that is, I know a much longer video than the others so far, but really because of the recursive CTE and understanding why it was helpful to solve this puzzle for iterating row by row all those moves, I thought it'd be helpful to try and talk through what's going on. I'm sure recursives are going to come up again, and so maybe we'll have some more opportunity to talk about them often throughout the advent of code. Thanks so much. I hope that was helpful and interesting, and we'll see you on day 6.